Welcome back to the Henry Ford College CIS-211 Web Server Administration Lecture Series. While this is lecture number 13, you may actually want to watch this video earlier in the semester. After you've watched the introduction, lectures 2 through 12 provide background information about some of the technical aspects of web servers in general. Lectures 13 and 14, however, are designed to introduce you to the concepts you'll need to complete the lab assignments for this class. In this video, we're going to jump in and get an introduction to Linux web servers. This class provides an overview for web server setup and administration on Linux web servers. We cover basic maintenance and security in this class, but it is not a full Linux administration course. If you are interested in going deeper with Linux and Unix system administration, check out the CIS-211 Unix administration class. Students in this course should be familiar with the Linux command prompt, and this class assumes that you know command line basics. HFC's CIS-129 Intro to Unix with Shell Scripting is a prerequisite for this class, so you may want to go back and review anything that you learned in that class as a foundation for the things we'll cover here. When you start working with Linux, one of the first things you hear about are Linux distributions. What exactly is a Linux distribution? It's an operating system made from the software collection that includes the Linux kernel, some sort of package management system, and a set of utilities and applications so that you have a full-fledged system. Linux distributions are usually based on the Linux kernel and the GNU tools and libraries. Most distributions ship with a window manager and a desktop GUI. Some distributions may contain proprietary software and may be paid versions. There are nearly 1,000 known Linux distributions in existence. Several of the most common distributions fall into three families: the Debian family, which includes Debian, Ubuntu, Raspbian, and Kali Linux for security and hacking; the Red Hat family, flagshipped by Red Hat Enterprise Linux, which is a paid version, but also Fedora for cutting edge, CentOS, the community enterprise operating system, and Alma Linux and Rocky Linux, which have been created recently since CentOS stopped being a direct downstream for enterprise Linux. Other common distributions include the SUSE family of Linux, including SUSE Enterprise and OpenSUSE. SUSE Enterprise is a paid version and OpenSUSE is entirely open source. The default name of the administrative user on any Unix or Linux system is root. This can be confusing because it's not the same as the operating system's root directory, and it's not necessarily the root user's home directory, which is titled /root. This is mostly the same as what happens when you use superuser or when you use the sudo command. One of the things you'll run into, starting with this naming convention, is that Unix-like operating systems are very cryptic. The key to the root user is that it is always defined by user ID 0 and group ID 0. Unfortunately, because it has all of the permissions, this user can break all the things. And I'm going to say sorry in advance because this class is going to have you working a lot as the root user. By following the lab instructions carefully, you should be able to avoid most, if not all, of the pitfalls that come with being the root user. Most, if not all, of the Linux distributions have other things in common, including the primary directory structure. The bin and user bin directories contain binaries or executable commands. sbin and user sbin contain binary commands for the superuser, typically only run as root or with sudo. The user and var directories contain system files. The etc directory, or the etc directory, as you'll hear me refer it to in the labs, contain almost all of your system configuration. For most distribution, /home contains the home directories for non-root users, and in some systems, /opt or /opt might contain files for specific applications. Certain applications, when installed, like to drop all of their files in opt. In the early days of the internet, we'd connect to a server to administer it and use it with telnet command, which was just a basic unencrypted terminal connection. As security became more and more important on the network, telnet usage was eventually replaced with secure shell or SSH. SSH provides remote terminal access over an encrypted connection. It can be used to tunnel other applications, so you could set up a connection for an application such as a web server or a database server listening on a port and tunnel that connection through your SSH connection. And SSH allows for multiple forms of authentication, including public key and two-factor auth. SSH can be subjected to brute force hacking attempts when passwords are allowed, which is why it is generally considered a bad idea to allow root to log in with a password remotely. And in some cases, it's a bad idea to allow any of your users to log in remotely by using a password. Aside from limiting password access, there are a few other things you can do to protect secure shell. When possible, protect your SSH port by the firewall and only allow connection from known safe hosts. When you can't do that, there are utilities such as fail2ban or other brute force protection scripts that you can run that will lock out and break connections that are trying to brute force attack your passwords. It's a common recommendation to never log in remotely as root, and in general, I think that's a good idea. However, I'm not opposed to logging in as root when you use key-based authentication and your logs can show which administrator logged in with which key. Aside from attacks from the outside, one of the biggest problems with logging in as root is if you have multiple administrators logging in, you won't know who actually did what. As long as your SSH logs are showing the key fingerprint for which user logged in, I think in a lot of cases that's enough security, especially for smaller systems that only have one or two administrators and aren't handling secure data or personal identification information. The biggest difference between different Linux distributions usually comes in package management and sometimes the organization of configuration files. Most of the Linux distribution families that I mentioned at the beginning use different package management tools. The Debian family is based on .deb packages, and these are commonly managed using apt, the advanced packaging tool. Red Hat and SUSE packaging, on the other hand, both use the Red Hat package management system. However, for the most part, they use different tools to manage packages under RPM. Red Hat family distributions use Yum and now DNF to manage RPM packages, where SUSE uses YAST, or Yet Another System Tool, as its primary management. Both of these distributions also contain the RPM command, but that is not the primary way to manage packages because it doesn't support dependencies and you have to do everything manually with RPM. In the last couple of years, I've also seen Alpine Linux become popular because of its small and lightweight Alpine package keeper. Alpine seems to be a great distribution for setting up minimal projects and is also used a lot in Docker containers. As it is with distributions, there are many more package management tools available. This class is based on Alma Linux, which is part of the Red Hat family, so here we will focus on RPM, Yum, and DNF. As mentioned before, RPM is the Red Hat package manager, and RPM defines a way of building, archiving, and managing packages. Built on that is Yum, the Yellow Dog update modifier. This was originally created for Yellow Dog Linux that ran on older Motorola-based Mac computers, but was ported over to Intel platforms to be used with Red Hat family distributions. Yum simplifies RPM package management by handling dependencies and other tasks, so that when you try to install a package that needs other packages, Yum can go find those packages and include them automatically. When installing packages with the RPM command, you must manually identify and select all of the packages that need to be installed. Yum takes care of that for you. In more recent distributions, and becoming the default in Red Hat Enterprise 8 and other downstream distributions, Dandified Yum, or DNF, is the next generation version of Yum, with new features, lower memory usage, and better performance. Most of the commands used by Yum also work with DNF, but there are new features and benefits. Yum, DNF, and RPM to some extent all support remote package repositories retrieved over HTTPS or FTP protocol. Packages are installed with the DNF install command and removed with the DNF erase command. When managing a system with DNF, you can use the DNF check update command to find out if there are any updates available for your existing packages. And you can update those packages with DNF update, which will automatically download and update anything on your system that has newer versions available. Again, dependencies are checked during update, and packages will only update as long as they have all the support they need to run the newer version. When a Linux system boots, the kernel starts up and looks for an application that is intended to manage all of the other applications running on the system. This service manager runs as process ID 1, and the current manager in Red Hat family and most other Linux distributions is systemd. Systemd is the init system that brings up and maintains all other user space systems. And what that means is you have the kernel running as a process, and then all of the other applications that are running on the system are considered to be running in user space. systemctl is the command that controls the systemd system and service manager. From the command line, you can use systemctl to start, reload, restart, or stop services. It can also be used to enable or disable services at boot time. Services controlled by systemd can be started at any time. Enabling and disabling those services only affect whether or not they start automatically. Systemd can also be used to list and check status on all of your services. When installing the new services needed to power your website, you'll need to enable auto start, start the service, and then check status to make sure everything is running correctly. The commands shown here step through that process for the MariaDB database engine. As mentioned before, the etc directory contains configuration files, which are mostly text files for most system operations. Some configuration files are stored elsewhere, but on modern system, most of the files you'll need to manage your web servers you'll find right here in this directory. Because this is a directory full of text files that you'll need to edit, this directory is very easy to break, so you'll want to make frequent backups of these files. Better yet, because they're text files, you can treat this directory as source code and use version control, just like you can when you're developing applications. So let's talk about backups for a minute. Backups are great, but full system backups are big. If you back up your entire server with all of the executables from the operating system, you'll have a backup that is several gigabytes in size, even if you're only running a small website. Over the years as a system administrator, I've had a lot of time to think about what do we really need to back up. When building websites, the most obvious thing to back up is your website. But if you're following modern development procedures, all of your website code should be in version control anyway. So you probably will have a copy local on your hard drive, a copy in a remote repository somewhere, and then the copy that is deployed onto your web server. The next thing we need to back up is our web content. And here I'm talking about file uploads for your content management system or other system that allows for uploads. We need to make sure that those files are backed up on a regular basis in case something happens to the server. Obviously, database contents need to be backed up, and so database backups are very important. But last, and certainly not least, is server configuration. If you don't back up your server configuration, you can definitely run into problems later. One of the most popular version control systems today is Git. And if you're not familiar with Git yet, you should become familiar with it soon. Git is software for tracking changes in any set of files usually used for managing source code during software development. Git was originally created by Linus Torvalds, the creator of the Linux kernel, to maintain kernel changes. Linus believed that it was important that Linux, one of the most popular open source platforms in the world, should be maintained using open source tools, so he created Git as a replacement for the tools that were being used at the time. As it turns out, Git is also great for tracking changes to your Etsy directory. There's only one thing you need to watch out for. Because you're copying files that are normally read-only down into the Git repository or the .git subdirectory under your Etsy directory, you need to make sure that that directory is set to 700 so that non-root users cannot access any of the files in there. Once you've done that, there should be no reason why there would be a security risk for storing your configuration in Git. Just like any other type of source code management, best practice for this directory is to commit your changes early and commit them often. Every time you make a change that gets something working on your server, you should add and commit those changes to the Git repository so that if anything breaks further down the road, you'll be able to reset all of those files back to a known working version. It's also a pretty good idea to save a remote copy of this directory as a backup. I've had servers break and have their hard drives die, and rather than restore the entire server, which was on a slightly outdated operating system, I was able to quickly spin up a new server and use the files from the stored Git repository to rebuild configuration onto a new server. So not only did I have newer hardware, but I had the updated operating system as well. The root user is intended to administer the server. Content on your server should not be owned by root, and content, especially for a website, should not be owned by root. And content, especially for a website, should not be owned by root. Also, your content in your website files should not be writable by the Apache web server user, because if there's any way that your website can be hacked, then your website files can be overwritten by the Apache user that's running that website code. Instead, you should create a regular or unprivileged user for this purpose. With some of the more modern systems like WordPress, Drupal, or Symfony apps, the web content user may need to be a member of the Apache group so that directories can be written for uploaded files or caching or other purposes that can be managed both by the running web server process and by your command line user. Once created, use this non-root account to maintain websites, data backups, and other changes. The first lab assignment in this class is an initial server setup, which will walk you through initial configuration tasks. In this lab, you'll install some recommended packages, add version control to your Etsy configuration directory, configure some basic firewall settings, perform system updates, establish key-based authentication so you're not vulnerable to password attacks, and create a user for web content ownership. In additional lab assignments for this semester, topics will typically include installing and configuring MariaDB database, installing and configuring the Apache HTTPD web server and PHP, configuring basic security, and installing a website. Thanks for watching this video. If you have any questions, be sure to contact your instructor. Understanding the basic principles in this video is important for your success in this class.